this is a 24 volt DC motor. This is a 36 volt DC dynamo. And this is also a 36 volt DC dynamo. Now, the motor is connected to both dynamos via a chain. Now, the ratio of the gearing is 1:1. So what's happening here? The idea of this whole setup is to try to get over unity, i.e. free energy, create energy out of nothing. It's an experiment. I wasn't convinced it would work, but now I know that with this current, conventional DC motors, it's virtually impossible. It's impossible. It's totally impossible. Now, I spent a lot of money on this setup. It's top of the range digital multimeter, a basic 12 volt lead acid battery, and the 12 volt lead acid battery, right? I'll show you. We connect it up, so the power is on. That's 12 volts DC, which flows through this wire here to a DC to DC converter, which is this machine here. What this machine does is it takes the 12 volt DC and electronically steps it up to around 25 volts, 24 volts DC, which is connected directly to the motor via a switch, which is a changeover switch, knife switch. So if I was to move the switch this direction, this is switching on the motor via the boost converter. So 24 volts DC will now go to the motor here. Watch this. So this spinning in a clockwise direction, this also spinning clockwise, and this also spinning clockwise. This transfers mechanical input power to the chain, which drives both dynamos. Now both dynamos are rated for 250 watts each, and this motor is also 250 watts. So the whole setup that I've got here is designed to enable the motor to feed power to the dynamos, so that the dynamos can then feed power back to the motor, thus enabling a perpetual state of motion. However, it does not work, not with this setup. Now in the future, I'll be developing this concept a lot further, and I will achieve 0 point energy within the next few years, sooner ideally. But this setup here cost me a lot of money, but it was not wasted. I learned a lot. I know that the reason why this motor can't power these two dynamos and then just the dynamos feed back into the motor is because of something called the back EMF, the back electromotive force, which is generated inside the coils of this dynamo. Now, the back EMF, when the dynamo is spinning and there's no electrical load connected, so it's open circuit, then it'll spin freely, as you've just seen, because there's no electrical load being applied to both of these dynamos. But as soon as I was to connect the load, I'll show you now. What happens is, inside the dynamo, a back electromotive force causes a mechanical force in the opposite direction to the rotation. So that's spinning clockwise, for instance, there. So you see, I can easily move this with my hand now. That's spinning clockwise. But inside the dynamo, when a light bulb or the motor is connected, or any sort of electrical load is connected to the dynamos, what happens is it becomes extremely difficult to turn. Extremely difficult. I'll show you now. I'll short circuit with the flick of the switch. I'll short circuit the dynamos. Dynamos are short circuited. And this is extremely difficult to turn, and that means there's not even any load really, it's just short circuited. That means that all the back EMF that's created inside this dynamo here and this dynamo here is creating a mechanical resistance, and the higher the speed, the higher the mechanical resistance increases. Now if I was to disconnect the dynamos, so there's open circuit, nothing's connected now, It's very easy to spin. It just spins a lot easier, and there's no way around this with conventional DC motors. The only way to enable over unity 0 point energy in this kind of arrangement is to totally redesign how a motor works. Now the motor is also a generator in reverse. So these are identical, just that the voltage of that one's 24 volt, but regardless, they're identical motors. Now what happens here, what needs to happen is there needs to be 0 back EMF, and there's 0 back EMF in that motor will allow that to spin. And if you imagine that these are just standard dynamos as they are, and this is a 0 back EMF motor, now the efficiency will increase to greater than 100%, like significantly, as far as I've researched. And my future projects will involve the development of said motor. Now I'll show you what happens when I connect the power and then switch to the dynamos. It'll instantly just stop. Watch this. So I'm going to move this down that way. That connects the motor power to the battery. Battery power connected. Now switching back so that the motor powers itself. See how fast it stops? It's a braking action. It slows down extremely fast when power is connected from the dynamo to the motor. If you move the switch down here, that means that the dynamo is connected to the motor, and that means up that way means that the battery is connected to the motor. Now there's not enough power being produced by this to drive both of these dynamos, and even so there's mechanical and electrical losses created in all of these machines. Friction in the chains, back EMF, friction inside the motors, resistance in the wires. So all of these things add up to effectively show you that it's impossible using conventional technology. We have to think outside of the box to enable this to succeed. Thank you for listening, and I hope this serves you well.